This video, let's take a look at some compound interest problems, the kind where you know you're going to compound it multiple times in a year. Like you have an investment of $2,000, it makes 9% APR. APR stands for annual percentage rate. And so let's say that your money is getting compounded monthly. Now you have two choices. If you're a visual person, you may want to think about that as being compounded monthly. So here is January, here is December. Over the course of that year, you're going to get 9% of your money. 9% return on your money. So what that means then is you're going to look at a situation where you're going to get it each month. So at the end of every month, 1, 2, 3. So then you're going to have 12 months of return, but they're not going to give you 9% at each of those points. They're going to give you a 12th of that at each of those points. So the key is, turn your rate into a decimal, 0.09. So then what I'm going to do on my calculator is I'm going to take 0.09 and I'm going to divide that by 12, and I get 0.0075. So that means that each one of these, they're going to give me 0.0075 extra money all the way through. But I already have my initial investment in there, so I'm getting my initial investment, which is 100% of my money, and then add a 1 to this, so 0.0075. So this is my multiplier. So every time I'm getting this much return on my investment each month. So now, here's my situation. I have $2,000. It's going to get multiplied by 1.0075. And in this case, it's monthly, so I typically put an M up here to stand for the number of months so I can make sure I remember to do that. So if the question said 1 year, I'd put a 12 there. If it said 2 years, I'd put a 24 there. Let's do 3 years. So if I do 3 years later, then my situation would be I've got $2,000 times 1.0075 because it gets compounded monthly, and then to the 36th power, or 12 times 3 is 36. So when I do it this way, 2,000 times 1.0075 and then raised to the 36th power, I get $2,617.29. So 17 and 29 cents is my total. Now that is kind of the visual way to do it. If you think about each hash marker, each month I'm going to get that repayment of that 9% interest. Now there is an equation way to do this, and so you may want to pause the video and write down this equation, but this equation can calculate all of that for you. It's I equals P times 1 plus R over N to the NT power. Now, P, principal, that's the money that you're putting in the bank. R is your rate as a decimal. Again, that's key. You've got to change your rate into a decimal, your annual rate, convert it to a decimal, and then you're going to divide that number by the number of times it's compounded per year. So if it's monthly, it's divide by 12. Quarterly, divide by 4. Then you're going to use that same number, the 12 or the 4 or whatever, and then times the number of years, and that's how you calculate your power. So if we wanted to do this same example that we just had, but using the equation, I would just simply write down 2,000, because that's this, and then I would write 1 plus 0.09 divided by 12 goes right there, and then to the 12 power times 3, because that's the number of years. And so this equation right here is the same thing that we had before, and you can see that once you type that in your calculator and try it, you're going to get this exact same answer right here. So you can either do these questions visually, where you're figuring out what happens in a year, or you can do it with an equation. So let's try another one, compounded quarterly, and let's again say 3 years. So if it's compounded quarterly, now I've got that same 9%, so if I'm thinking visually, well, that's January to December, there are 4 quarters in a year, 1, 2, 3, 4, then in this first quarter, I'm getting that 9%, but that 9% as a decimal is 0.09 divided by 4, so in each quarter's time, 0.09 divided by 4, I get 0.0225 on my money, 0.0225. Which if you think about it, that's 2.25%. But I want the decimal. That's the number that goes in the equation. So I'm going to get that 4 times in a year, add it to 1. 0.0225 is going to be my multiplier. My original investment was $2,000 times this. And then I've got it 4 times a year for 3 years. 4 times 3 is 12. So in this case, I would take it to the 12th power because it's a quarterly investment for 3 years. Now before I show the answer to that, I would like to do this also with the equation. So if I bring down the equation again, and the way that we'd look at it is, okay, I'd put my 2,000 there, then I would have 1 plus my 0.09 over 4, because there's 4 quarters in a year, and then I'm going to have that to the 4 times 3 power, because I'm doing 4 quarters times 3, and I'll show you how to type that one in then. So I go 2,000 times, and then 1 plus. And now when I do this, I've got to make sure that I put another set of parentheses there. So left parenthesis 0.09 divided by 4 because I want it to calculate that first. Close out that other parenthesis that was here, and then take it to the 4 times 3 power. You can either put 4 times 3 or you can just put 12. I'm going to put the 12 to make that calculation easier. Otherwise, you'd have to use parentheses again. And I end up with 2612.099. Now money rounds to 2 decimal places, so that third place is going to round it up to a 10. So 2612.10. So 2612.10 is my return on a quarterly investment. Now something interesting to notice is that when you compound monthly, you get more money. When you compound quarterly, for the same amount of time for the number of quarters, you get a little bit less money. So the more compounding you have, the more money you're going to earn because you're earning extra interest on top of the interest. And so the two ways to do it are visually over here, or you can do it with the equation plugged in here, just as long as you know what all that equation stands for. So good luck with your interest compounding equations.